Alright, here's the infamous ambiguous case of the law of sines. Okay, so there's going to be two cases. One where angle A is going to be greater than 90, or angle A is going to be greater than or equal to 90, or less than 90, or greater than or equal to 90 degrees. Okay, and the situation I'm talking about is this one right here. Okay, so let's say that this angle was angle A, so I know that's angle A. Now some of you guys are going, oh, you forgot to draw the other side. No, I didn't. Trust me on that one. Okay, so this side would be B, little b to represent side length, and this would be A. So this is the situations that could pop up. Okay, so case one, if A is less than B, now 90 degrees. Now let me tell you this right now. When working with ambiguous case of the law of sines, it's almost like choose your own adventure book. Okay, in the choose your own adventure book, you see the situation, then you choose the right path. In this case, you're going to be given the situation. So for example, if case one is you have angle is less than 90 degrees, okay, then you follow these three situations, or this fourth one. Okay, if it's greater than or equal to 90 degrees, then you follow these two situations down at the bottom. So it depends on what you start with. And then once you follow it, you have to look at A and B. Okay, so this is first. So you look here first, or look here first, depending on which one you have. Okay, and then you look here second. Okay, same thing here. This would be second, and this would be second. And then you lastly on this one's the most trickiest one, because you have to look at these three situations. So this would be the third place you would look for your adventure in trig, your adventure in law of sines. Okay, so this doesn't pop up very often. Alright, so let's take a look at this first one right here. Okay, so A is less than 90, A is less than B. Okay, so what is actually happening? So what I'm also going to be doing is looking at this right here, okay, because this is going to be, that is going to be B times the sine of A. Okay, so that side length is going to be there, so we're going to compare. So now if A is less than this, okay, here's what happens. So I try to draw, well, I'm not going to draw it right there. Okay. Alright, so A is less than this, so I draw my line straight down. Okay, here's angle A. Okay, here's side B, here's side A. Okay, and this right here, this is B times the sine of A. Okay, if this side is less than this side, then when I try to swing it, and what you're going to do is try to swing this side down. If I try to swing it, no matter what, I'm not even going to touch the bottom. I have to have that met up, because I have to somehow meet this imaginary red line that I'm going to draw out. The red line is not permanent, but it will be there if A is long enough. So if this situation happens to where A is not longer than B times sine of A, and that's the only numbers I have to compare, I don't do this problem because there's no triangle for it. And this is why your geometry teacher said you cannot do this. So no triangle exists, you don't even finish it. And this is the really sweet situation when you come across this problem to where A is less than B times the sine of A. When that happens, well, first off, you have to follow all three parts. Okay, then you don't have to finish the problem. Now, you can already imagine how the rest of this is going to go, because if A is equal to, or if A is equal to it, okay, my imaginary side has to go this way. Okay, there's A, here's B, and A equals B times the sine of A. Ooh, let's get rid of that caps lock. Good night. A equals B times the sine of A. Okay, alright, so since it equals that, guess what? You are now dealing with a right triangle. So you can finish this problem. So one right triangle. Okay, so now that you're dealing with that part, you can actually finish this problem because you're dealing with one right triangle. Now, if it's greater than, here's the tricky thing. This is really kind of cool how this works. Okay. Alright, so this is angle A. This is side B. Oops. This is side A. Okay. Oh, and let's change this back to green. Okay. Alright, and then once again, this is B. Now this is not exactly drawn to scale. B times the sine of A. Okay, now if A is longer than that, I could have this one situation where it actually works this way. But I could also have this other situation where if I swing it over here, guess what? I would actually have the same triangle. So I could actually have two situations where I could have both the same triangle and they just work out to be the same. It's the weirdest thing in the world, but it does pop up. Okay, so when you're dealing with this one, you have to deal with two triangles. So you actually have to find two different triangles that the possibility could be. Alright, so those are the tricky ones right up there. I call them the tricky triplets. Okay, now this one, what if A is greater than or equal to B? Alright, if it is, you're in luck because you only have one triangle to work with. Okay. Alright, now I do want you to see one thing. Let's say A is B. Okay, if it's right there, we don't even care about the B sine of A because no matter what, it's always going to be greater. So that's when this one is greater than or equal to B. So we're either dealing with an isosceles triangle or a really obtuse triangle type thing. Okay, so this one you're only going to have one triangle to work with. Okay, alright, now case 2. What if angle A is greater than 90 degrees? Okay, now if A is less than B, okay, so I'm going to be very tricky in how I draw this. So B, this is side A. Let's get red. Okay, the triangle should be completed somewhere down here because angle A is going to be right here. Okay, if A is less than B, no matter how hard I try to swing it, no matter what I do, nothing's going to happen. So this one's going to be no triangle works. Okay, so this is another situation that's a lot like this situation up here, to where no triangle can exist, so therefore I don't have to finish this problem because there's no possible way of it actually finishing it. Okay, however, if I do know that A is greater than B, okay, I am going to be making one triangle right there, which makes sense because, you know, if A is greater than B, it's like taking a longer piece and then just moving it down. Well, yeah, you can actually have it. So one triangle. Okay, now on this one we don't compare it to B sine of A, but these ones we do compare. Okay, and let me just finish it by drawing off. Okay. Alright, so you do have to pay attention to these rules. B times sine of A. You do have to pay attention to these rules because if you're working on a problem that's impossible, you just did it for no reason and thus kind of messing yourself up. You got to flow. You got to have a flow in here. You have to follow these rules and then choose which set of triangles you could have. So there are 1, 2, 3 situations where you have a triangle and it's in these 3 spots. So let's actually use a different, yeah. So you have either this situation, or this situation. You're using one triangle. However, on the flip side, you also have 2 situations where there could be no triangle. So you could spend your time, if you don't pay attention to these rules, solving for a triangle that actually doesn't exist. Okay? And then the infamous one of all, the lovely one where there's two triangles that exist. Okay, and I want to talk about that one. Alright, so this one right here is the one I would be looking at. So angle A is 51, side A is 40, side C is 50. Okay, so I go back to my very busy screen and I go, okay, first I look at the angle of angle A. Is it greater than or equal to, or is it less than or equal to that? Here, let's get rid of this down here. It's just bothersome. There we go. Alright, so I'm going to look at it and I'm going to say, oh, it's less than 90. So I'm going to focus next on comparing A and B. So I go back. Alright, A is less than B. So I go back. A is less than B, so I have to pay attention to these three possible situations that come up. Now I'm going to compare A and B times sine of A. Okay, so A is 40, and I'm going to compare that with, and use an inequality on 50 times sine of 51 degrees. Okay, so that one's pretty simple. So I go to my graphing calculator. That's going to be 38.85. So I definitely know that 40 is greater than 38.85. Okay, so now I need to go back and look at the situation where A is greater than B. Oops, went back too far. Okay, uh-oh, two triangles. Oh no. So I'm going to actually have two triangles that can be made out of this mess. So I'm going to draw both situations. Okay, first situation would look like this. Okay. Alright, so this would be 50, this would be 40, and this would be 51 degrees. Okay, and I would just solve for everything in here because you actually have everything all set up. You could use law of sines. Now obviously you would probably want to find this angle first. Let's call this, well, since there's two triangles, I'm going to call that B prime. This is going to be C prime. And this is going to be little c prime. Okay. Alright, and you'll understand why in a second. Okay, now the other situation that could happen is I could have a totally different type of triangle except have the same measurements. So this is kind of cool. Okay, so this would be 51. Alright, so I have these two situations set up right here. Okay, now here's the tricky part, is just working with this one, okay? Alright, so first off, I would find angle B first, okay, and that's the most important part. So I'd do sine of B prime divided by 50 equals sine of 51 degrees divided by A, okay? Now, sorry, A, that should be a little, that should be 40. Jeez Louise, I'm slipping my old age. Okay, so now that I have all this set up, okay, I do my cross multiplication. So this is 40 times the sine of B prime equals 50 times the sine of 51 degrees. Okay, and then I just divide both sides. Uh, 50 times the sine of 51 degrees. Okay, and I'm going to divide that by 40. Okay, now I'm going to do the sine inverse of that side. Okay, so do the sine inverse of or the arc sine of that, and I get 76.27 degrees. Okay, so this is 76.27. Now, immediately, before I do anything else, I'm going to go 180 minus that to get this angle right here, which is going to be 103.2 or 0.73. The reason why I do that is just that I have these two angles set up, and then I can solve the rest of triangles, because most people always make a mistake on this part and not pay attention to this rule, that because I can redraw it in here, these two angles will be congruent. Okay, and thus making these two supplementary. So please understand that rule. Thank you. Bye.